right, so this is 2013, number 3, Lucy from BC. This is the one that you asked. I'm actually going to post this both on the BC and AB website classroom because this is a question that is in both of them. All right, so let's get started. Hot water is dripping through a coffee maker, filling a large cup of coffee. The amount of coffee in the cup at time from 0 to 6 is given by the differentiable function c, where t is measured in minutes. Selected values of C of t measured in ounces are given in the table above. So this table is all about C, where C is the amount of coffee in the cup. Got it? A. Use the data in the table to approximate, keyword there, it's an approximation of the derivative of C at 3.5. Show the computations that lead to your answer and indicates units of measure. So when they tell you indicate units of measure, you get a point just for the units. So this is a 2-point problem. One for your answer, one for the units. So keyword there is approximate the derivative. There is no function here to take a derivative of, so I can't just take a derivative. We have to remember, what does derivative mean? Derivative means slope, right? So I could figure out the slope at 3.5 by looking between 3 and 4 here. These two problems right there. And we're talking about good old-fashioned slope from 8th grade. y2 minus y1 over x2 minus x1. So in our case, that'll be 12.8 minus 11.2 over 4 minus 3, which ends up being 1.6 over 1, which is 1.6. Units of measure, well, the y's was ounces per t was minutes, ounces per minutes. So that means like at 3.5, approximately this amount of coffee was increasing by 1.6 ounces per minute. So there you go. Quick, easy, 2-point problem. That's just them making sure you understand that derivative is slope and you're using the same old slope from before. All right, number 2. Number 2 says, or part B, is there a time from 2 to 4 at which the derivative equals 2? Does the derivative ever equal 2? Again, what does derivative mean? Slope, right? So is there a time where the slope is ever going to equal 2? Well, I'm going to be looking around over here. I'm going to try to find something that evens. Right here, actually. Yeah. If I do 12.8 minus 8.8, that's 4 over 4 minus 2, that's 2. 4 over 2 equals 2. Now, this is, remember what slope is, the average rate of change. They want to know, is the instantaneous rate of change ever going to be the same? What does that sound like? That's mean value theorem, right? Remember mean value theorem? That's the example. If I was driving from here to Madison and I was going an average speed of 72 miles an hour, that means at some point I had to have gone 72 miles an hour. All right? So you would then write by the mean value theorem, and you can, this is one thing that you can abbreviate. You can say MVT because they know what that is. There is at least one time between 2 and 4 that the derivative equals 2. That's a 2-point problem. If you do not get that, that is fine. It's a quick, easy 2 points. Maybe you guys figured out that the slope was 2. You got 1 point for this. And then you get 1 point for your explanation. Got it? It's okay. if you forget that part. It's an easy mistake. Try to get the slope part at least. You try to get as many points as possible. All right, part C. Use a midpoint sum with three subintervals. What does that mean? That's MRAM. Midpoint rectangular approximation method of equal length indicated by the table in the table to approximate the value of the 1/6 from 0 to 6 of CAT. Using correct units, explain the meaning of this. Well, let's first calculate it, and then we'll explain it, because there's a reason why that 1/6 in the front should be a hint. So I'm going to approximate using MRAM. So I still have the 1/6 because that's still hanging out. MRAM, it's rectangles. We're finding the areas of rectangles and adding them all together. Got it? There's 3 rectangles. It said 3 subintervals. So if I'm going from 0 to 6, if you can't figure this out, easy. You could do 6 minus 0 divided by how many rectangles? 3. That's going to be, it goes by 2. So I'm going from 0 to 2, 2 to 4, 4 to 6. So that means the bases of all my rectangles are 2. So the first rectangle is going to be base is 2 times the height. It's MRAM, so I'm using the one in the middle, which is 5.3. Plus my second rectangle, 2 again, because going from 2 to 4 is a base of 2. Using the one in the middle, it's 11.2. Plus 2 times the third one is 13.8. All right, let's figure all that out. That's going to be 1/6 divided by, this will be 60.6. Divide all that by 6, that's going to be 10.1. Now, using correct units, explain the meaning of the problem. What does that 1/6 mean? That's really that 1 over b minus a times the integral. That's the average value. So you would say, all right, that, let me erase that. Okay, you would say that the average amount of coffee in the cup between 0 and 6 minutes is 10.1 ounces. And that is our explanation. So, here's the deal. This is a 3-point problem. You get 1 point for doing the MRAM correctly. You get 1 point for getting 10.1, and then you get 1 point for the explanation. All right, D, last one. The amount of coffee in the cup in ounces is modeled by that. B of t equals 16 minus 16 e to the 0.4 t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. Okay, what does the word rate mean? Rate means average rate of change. It means slope, which in this class means derivative. So you are taking the derivative. I can totally see a problem like this, AB, being on your exam in May. All right? All right, so derivative 16 goes away. So now I've got this part here. Let's see. Derivative of E, we've got negative 16 is just going to be hanging out. Derivative of E is e to whatever, negative 0.4t, times the derivative of the inside, which is negative 0.4, right? Multiply these two things out, you get 2 negatives make a positive. That's going to be 64, move the decimal, so 6.4 e to negative 0.4t. Then they ask you to plug in 5. The derivative at 5, so that's going to be 6.4 e to the negative 0.4 times negative 0.4 times 5. negative 0.4 times 5 is negative 2, so we can say 6.4 e to the negative 2. Yeah, and it's a derivative, so it would be just like part A, ounces per minute. And there you go. It's a quick 2-point problem. 1 point for the derivative, 1 point for the answer when you plug in 5.